and welcome to the very next video lecture on higher order linear difference equation with constant coefficient. In the last learning video, we have already seen the introduction, order and degree of the difference equation followed by the solution of difference equation. And if you remember, if we have a difference equation like this, and if depending on this Vn not equal to 0 and equal to 0, we have the solution. Like Yn is equal to Cf is the solution for homogeneous, and if it is not equal to 0, then Yn is equal to Cf plus Pi is the solution for non-homogeneous difference equation. So whether it is homogeneous or non-homogeneous, we have to find out complementary function. So in this learning video, we are going to start with complementary function. So let us start with this. So here, for our convenience, we are taking a second order linear difference equation with constant coefficient, because most of the time we would be having a second order difference equation. Okay, so for our convenience, we are considering, suppose this is the second order linear difference equation with constant coefficient, then f of e equal to 0 is called an auxiliary equation of this difference equation, and once this auxiliary equations we get, we can solve this auxiliary equation. This auxiliary equation may be a quadratic or cubic depending on the given equation, and depending on the quadratic or cubic equation, we have as many as roots. So if it is a quadratic equation as we are considering, so how many roots it will have? It will have 2 roots. So I am taking, say, the roots are m1 and m2. Now once you get the root as m1 and m2, then there are how many possibilities? 3 different possibilities. And what are these different possibilities? Either this m1 and m2 are real or complex. Okay, then in real also there are 2 more cases. Both the roots are same or both the roots are not same. Okay, so 3 possibilities are there. So I am writing the first possibility, which is m1 and m2 are real and not equal. Real and not equal means m1 not equal to m2. Now the second case says m1 and m2 are real and these are same. m1 is equal to m2, say m. Okay, and at last m1 and m2 are complex. m1 and m2 are complex means this may be of the form a plus minus ib. Okay, so let us see, if we have 2 real roots and both the roots are different, then in such case complementary function would be c1 m1 power n plus c2 m2 power n. This table is going to play a very vital role in writing down the solution of difference equation. So if you understand this, then this is going to be really very interesting one. Okay, so this is complementary function for this. Now suppose we have 2 roots and both are same, say m. So my complementary function would be c1 m to the power n plus c2 m to the power n, and you just have to multiply the second solution by n. Okay, for complex roots you have complementary function as r to the power n c1 cos n theta plus c2 sin n theta. Okay, and here in the case of this complex roots, you have to find out r and theta as well. So here this r is nothing but the magnitude of this complex number, which can be given as under root of a square plus b square, and this theta being argument of this complex number is given by tan inverse of b by a. Okay, so these are the 3 rules. These are the handy ones in finding out the complementary function. So I think we can take some quick problems to work out with. Yeah. So the very first problem is example number 1. Solve ux plus 2 minus 4 u of x is equal to 0. Suppose you have this problem, and as you can see it is written like solve ux plus 2 minus 4 ux is equal to 0, and as you can see the right hand side is 0, so this is homogeneous and its complete solution would be just CF. Okay, so let us start with this. So we start with given this. Okay, then after writing down this given, we try to write in terms of E to get the auxiliary equation. So you can write here E square ux minus 4 ux is equal to 0. We have applied the definition of shift operator. Okay, if you don't know, then I am writing here y n plus k is equal to e k y n. Here we have ux. Okay, so this can be written as e square ux minus 4 ux as it is. Now let me write that is e square minus 4 operating on ux is equal to 0. So what is its auxiliary equation? Its auxiliary equation is, what is it? E square minus 4 is equal to 0. So what is E? E is equal to plus minus 2. Now see the nature of root and try to write down the complementary function. For the first and second example we will make use of this, and for third and fourth example we will try to write on our own the complementary function. So as the roots are m1 and m2, that is roots are plus minus 2, so plus 2 and minus 2 are different, so this falls under the first condition of this table. So what would be complementary function? Therefore complementary function is, what is it? C1 2 to the power x plus C2 2 to the power minus 2 to the power x. Now you may be wondering like, sir, here it is written n and why you are writing x? Okay, this is because here we have equation in terms of n. See here the independent variable is n, here the independent variable is x. Okay, so this is the complementary function. Therefore the complete solution is, what is it? Ux is equal to CF, that is Ux is equal to C1 2 to the power n, plus C2 minus 2 to the power x. Okay, and don't forget to write where C1 and C2 are arbitrary constants. So is this clear? If this is clear, then we can take some other variety of problem. So let us take the example number 2 now. So I am taking second example, which is delta square minus 5 delta plus 6 operating on yn is equal to say 0. Okay, so we have this on a very similar lines, we will solve it. So this is delta square. So I will write this delta square in terms of e minus 1. So this is e minus 1 whole square minus 5, delta is e minus 1 plus 6 operating on yn is equal to 0. Here you can give the reason like delta is equivalent to e minus 1. Okay, now solve this. When you solve this, what you would be getting? You would get e square minus 2e plus 1 minus 5e plus 5 plus 6. Okay, operating on yn is equal to 0. That is e square, then this is minus 7e, e square minus 7e, 5 plus 6, 11 plus 1, 12 operating on y is equal to 0. Write down its auxiliary equation. What is its auxiliary equation? Its auxiliary equation is e squared minus 7e plus 12 equal to 0. Now you can make use of the calculator to get the eigenvalues, to get the roots of this equation, okay? Or you can solve it manually. So if you can solve, so 4 3s are 12, 4 and 3 is 7. So we have the roots as e is equal to 4 and 3. So this is again the problem where you got the roots as different roots, okay? So here it is going to be c1 4 to the power n, c2 3 to the power n, okay? I have written c1 4 to the power n plus c2 3 to the power n. One can may write c1 3 to the power n plus c2 4 to the power n. That is also correct, okay? So no problem with that. Then complementary function is yn is equal to cf. So this is yn is equal to c1 4 to the power n plus c2 3 to the power n. This completes the complementary function for this. Okay, now we can take one more problem here. Let us take some different variety of problem. So solve yx plus 3 minus 3yx plus 1 minus 2yx is equal to 0. Suppose you have this equation. So again on a very similar lines you can start with, given this, then apply the definition of shift operator. So you can write it as e cube yx minus 3e yx minus 2 yx equal to 0. Now you can take out this yx common. So this is e cube minus 3e minus 2 operating on yx is equal to 0. Okay, now you have this equation. You can get the roots of this with the help of factorization. If not, then apply synthetic division method. If not, the simplest way is to use the calculator. Okay, so its auxiliary equation is what is it? E cube minus 3e minus 2 is equal to 0. Okay, when you solve this, you would get e to be 2 plus minus 1. So these are the three roots: 2 plus 1 and minus 1. Okay, now you see the nature of the roots. Again, real and not equal, and now here there are three roots because we have the cubic auxiliary equation. So you can write here CF is equal to C1 2 to the power x plus C2 1 to the power x, C3 minus 1 to the power x. This is complementary function, and then you can write down the complete solution. Therefore the complete solution is what? Yes, yx is equal to cf. Then you can write that is yx is equal to c1 2 to the power x plus c2 1 to the power x plus c3 minus 1 to the power x. Okay, as you know that 1 to the power x is 1, so in the final answer you can remove this 1 to the power x. You can write c1 2 to the power x plus c2 plus c3 minus 1 to the power x. Now let us take one interesting example to conclude this learning video. So we have the fourth problem. So we have the fourth problem, which is yx plus 1 minus 2yx cos alpha plus yx minus 1 is equal to 0. Now we have this equation. Now see the beauty of this equation and try to find out the auxiliary equation and then the roots. So this is yx plus 1, this is given. Now I can write this one as e yx minus 2 cos alpha yx. Now as you can see here, the suffix is minus 1, so I can write it as e power minus 1 yx is equal to 0. Okay, now collect the terms of yx. So this is e minus 2 cos alpha plus this e can be written as 1 upon e yx. Okay, now you write down its auxiliary equation. So its auxiliary equation is, what is its auxiliary equation? Yes, you can solve this. E into e, take LCM, e square minus 2 cos alpha plus 2 cos alpha e plus 1 is equal to 0. This is its auxiliary equation. Now we have to solve this auxiliary equation manually to get the roots, because this is not easily solvable. So the basic way to find out the roots of the quadratic equation is the basic formula, minus b plus minus under root b square minus 4ac by twice a. So this is minus minus plus, plus minus under root. What is b square? Oh sorry, this is minus 2 cos alpha plus minus under root b square. So coefficient of e is 2 cos alpha whole square is 4 cos square alpha minus 4. A is 1, c is 1, whole divided by 2 into 1. Okay, now you see this minus minus become plus. This is 2 cos alpha plus minus this 4 you can take common. So under root 4 is 2. Then this is under root cos square alpha minus 1 upon 2. Okay, now these two get cancelled with this. So we remain with e is equal to cos alpha plus minus. What is this cos square alpha minus 1? Cos square alpha, see, sin square alpha plus cos square alpha is equal to 1. Okay, so what would be cos square alpha minus 1? Cos square alpha minus 1 is equal to minus sin square alpha. So this is under root minus sin square alpha. This can be written as cos alpha plus minus under root sin is sin square is sin, and under root of this minus is iota. So we got my roots to be now complex, and for this, what would be my complementary function? My complementary function would be r to the power x c1 cos nx plus c2 sin nx. Okay, c1 cos x theta plus c2 sin x theta. Now I need to find out here this value of r, that is magnitude of this, and this theta argument of this. So let me find out here only. So r is equal to, now r is equal to under root of this square plus this square. So under root of cos square alpha plus sin square alpha. This is the basic identity. So this is under root 1, that is 1. What is theta? Theta is the tan inverse of b by a, means sin alpha by cos alpha. So this is nothing but tan inverse of tan alpha. So tan inverse of tan alpha, inverse and tan get cancelled, we remain with alpha. Okay, now we can write down the CF. Therefore, CF is equal to, what is it? R. R is 1. So this is 1 power x. C1 cos x theta, so x alpha, plus C2 sin x alpha. Okay, so this is the complementary function, you can write down the complete solution. The complete solution is y is equal to CF, yx is equal to CF. Okay, so what is it? That is yx is equal to, what is CF? 1 to the power x is 1. So this is C1 cos x alpha plus C2 sin x alpha, where C1 and C2 are arbitrary constants. Okay, so I hope the problems that we have taken here is clear to you. In case of any doubt or any queries, you can contact me or you can write in the comment section. So this is what we have in this learning video. So thank you for watching and enjoy learning mathematics.